All right, we need to get started here, but there's a couple things I need to tell y'all. I asked for 12 and 14 in Google Classroom before you guys came today, but if for some reason you were not able to upload those, the last chance to get credit for those is to turn it in now. Not after the quiz, but before the quiz. So if you are not sure if you turned something in, I would turn it in just to be careful, or just to be extra sure. I don't think this applies to much, but remember, I do not take late work past the unit assessment. So if there was anything, I can't imagine what it was, but anything I took up that you didn't have completed, or you went back and completed it to get half your points back, this would be your last chance to turn that in as well. Also needs to be in the basket. And after that, I do need your phones / smartwatches turned in to the side of the room, please. There's a place for them to hang up over there. If you can, put them where it matches your seat number, but if you're not sure of your seat number, just make a good guess. That's fine. Just put it in here. I'd rather you be safe than sorry. I don't mind double checking, but I won't take it after we start, so.
Could you double check for me?
I'm not going to look on the computer now. You can turn in the hard copy if you want to be sure.
Is it the lemons review?
And the one-page worksheet. All right, and then last thing before I give you your quiz to start on. You should have picked up a handout that needs to be number 16 in your binder. It is a unit reflection handout. And for those of you that had me last year in pre-calculus, I know I had you do that during that time too. But I think it's even a little bit more important in calculus because, again, in May, April, you're going to want to remember what it was about limits that you struggled with, or you wish you had studied more, or whatever. And so that unit reflection is a good way to document that. But once you're sure I have your homework papers, you've got your phones and smartwatches turned in, you filled out the first two parts of the test reflection handout, and you cleared off your desk, I will get you a quiz to start. This is a no computer test.
Yes, I was just checking to see if I Thank you.
Alright, first, some of the questions are going to be easier, and we're going to take a little more thought. I would recommend that you try to pace yourself well. Careless mistakes. Actually, in the past, I think one of these questions ends up being one of the more missed questions, even though it's not one that is claimed to be one of the hardest. So, just have to be careful. Or you get too deep on it, please put your name on there. You do not number this one. We don't let you keep the major assessments. I will keep those in a folder for you. And that's part of the reason you need the unit reflection handout. But there are multiple forms, so please don't be tempted to look at anybody else's paper. It'll end up being wrong, and it's usually pretty obvious where your answer came from. This is no calculator. Except for the FRQ. So if you guys look at the back page real quick, it says you can use a calculator. I don't think you really need a calculator, but the way this is going to work is go ahead and work your quiz. When you're sure that you're finished with the first page, you can tear it off, and then you're welcome to get out a calculator when you don't have your first page in front of you anymore. So you're welcome to get out a calculator for the last page, but only after you turn in the first page and you're done with it.
Is it select all that apply? Is it select all that apply, or is it just one? That's your
Just one.
one.
Okay, and then the last thing I can think of, and then I promise to get out of your way. Last year we graded all of these as 1 point each, but the free response is always out of 9 points. That's how the AP exam does it, so we grade it the same way. So 9 points for the last page, 13 other questions, so that's a total of 22 points. And my B-Day class won't take it until tomorrow. It is in your favor not to tell the B-Day students what was on the test, what you thought was hard about the test, what you wish you had studied for the test, because we wait and see what the scores look like before we curve them. Last year, we took these 22 points and graded it out of 20, so we gave like 2 free points, but that may not apply this year. You need to do the best that you can. If everybody else does very well and you do poorly, there may not be a curve. So Okay, that's the last thing I can think of. But if you guys have any questions about the directions, I can help. I cannot explain the questions to you, and I cannot help you with the math. And of course, no partial credit on the 1 point questions. And if you guys turned in a hard copy of some of your classwork and homework, it's over there by your phones. So after you turn in the quiz, you're welcome to grab your phone back. And if you gave me a hard copy of your classwork, you should pick up that to put back in your binder. You won't be able to go back to this part, so you're sure you're done with it? Okay, so just making sure. Again, when you guys finish the front and back of the first page, you should try the FRQ on page 3 without a calculator, because I don't think you need it. But if you really want a calculator for that, since that's allowed, you can tear off your front page, turn it in. That will be done and finished. You can't go back to it. But then you can get a calculator and do the FRQ part. If you do approach it that way though, make sure your name is on the second page also.
sure you put your name on the second page.
Okay.
Did I get your first page?
I'm sorry.
You gotta turn your first page in. if you're going to use a calculator.
Give me 14, 12.
Yeah, I said before class. It's late now. I can't take it. I don't know how to emphasize it anymore.
I've got a question. Does, you know how like you write UNT for undefined?
Okay.
Does that count as does not exist?
You need to break that habit, but I knew what you were saying. So.
Okay.
So just turn this on.
Yep. Yep, in the basket.
Mr. Johnson, this is asking if the graph is continuous at x approaching 1.
Is the whole thing continuous?
Okay.
In the basket.
So you can just like rip one after this out.
What?
If I want to calculate, I just rip the first page.
You need to turn this one in, and you're done with that. Put your name on that one, and then you can use the calculator.
Well, you only have to use one part of the definition.
If you think it's no.
We should put these in here as well.
Your name's on that one too, though. Yep. in the basket. Thank you.
Sign out to pass. done with my quiz, so got another handout for you. But before we move on to the other degree, unit reflection, you should answer the next couple questions while all that's fresh in your head. So again, I hope that you get a couple things out of that. I'd like you to see, maybe it was harder than you expected, and next test you need to study an extra 30 minutes. Or maybe it's easier than you expected, and you can study less next time. But also, realize, man, I wish I had practiced unit circle more, or known the definition of continuity better, or if you don't know it now, that's the type of stuff you're going to want to review in April, May, and that's not going to be fresh in your head that long down the road. So put it on your unit reflection, and it goes in your binder as 16. Does that say 16?
Yeah.
Now again, I will try to have those grades put in gradebook by the end of the day tomorrow. But again, with the curve on this one, it kind of just depends on what the scores are. So I'm also a little dependent on Miss Cross to get hers graded to see. Because we get the same curve, of course. So between her classes and my classes, overall how it goes. But I suspect, well, like what we did last year, it was 22 points. We'll probably grade it out of 20, so you get 2 freebies. If you're not happy with how you did, the good news is it's probably only going to be a 20-point quiz, maybe a 25-point quiz, where most of our assessments are 50 points. If you didn't like limits, the good news is we don't use limits almost the whole rest of the semester. So we kind of just have to tuck that knowledge away. But your success in the first unit does not dictate how the rest of the semester is going to go. And probably, I can't promise this because Ms. Cross has to agree to it as well, but most years we let the semester exam also replace a low assessment grade. So hopefully that's not your limits, but if it ends up being that, that is at least a second chance. Okay, so I guess that makes this number 17. Yeah, this is number 17. So pretty much everything else we do the rest of the semester is about derivatives. We'll talk about what a derivative is. In this handout, we're going to talk about the definition of a derivative, where it comes from. The second unit, we practice taking derivatives. There's some rules we have to learn. And then applications of derivatives. And that ends up taking up the rest of the whole first semester. So we pretty much live and die by derivatives. And then next semester, we do integration. But integration is the opposite of deriving. So the better you understand derivatives, the better that carries over. Okay, so for derivatives, before I just go out and tell you what a derivative is and how we're going to work with it, what it looks like visually and such, if I asked you, what is the slope of this equation, what would you say? 3. It's the number next to x, right? mx plus b. Or if it's written in point slope is what we like to use. What would you say the slope of this one is? 3. It's right here, right? So in Algebra 1, you look at a lot of linear problems and you talk about slope. Then in Algebra 2, you move on to stuff that's not linear, like x squared. And all of a sudden, your teachers stop asking you about slope, because this is where derivative comes into play. What do you think the slope of x squared is? Well, let's write it like this. If we call this f of x, it's good for you all to get used to this notation. If this is the function if we put one little tick mark here, this means we're talking about the derivative. One little tick mark. No tick mark means you're talking about the function. One tick mark means you're talking about the derivative. What do you think the slope is at x equals 0 at this moment? Good. It's 0. So visualize, this is called a tangent line. At that moment, the slope is 0. But do you see how it's going to just depend? Like maybe at x equals 2, can you see that the slope is positive? Something positive. Over here, it's something negative. Do you see how it changes? So a derivative, it would be something negative. A derivative is really just slope. It's just that we need, in the real world, you want to be an architect or basically anything with math or science, most stuff isn't built out of straight linear lines. Most stuff have curvature to them. Cars are not going to be very efficient if they're very boxy. They need the curvature to them. So that's what we work with. We want to be able to determine how big is this slope here, how big is this slope here, how big is this slope here. Really the only one that we can put a value to is right here. At that instant, you should see that the slope is 0. So slope and derivative, very, 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 very similar. 99% the same thing. So for a while, just rephrase it as that. All right, so we've got some notation here. Sometimes, so I was drawing in tangent lines. Do you guys remember that term, tangent line, from geometry? Tangent line is a line that touches usually a circle, but in calculus it's a function at exactly one point. So just like right here, I don't know, it's kind of a big tangent line, but there's the tangent line. It's kind of a visual of what the slope is at that moment. So the slope of the tangent line can also be written as f prime. This prime mark, this little tick mark, means we're talking about derivatives and not functions. And then this guy, this is the definition of a derivative. So I'm going to show you where this comes from and how to use it. And we're going to use it a couple times on our notes. The good news is that College Board does not make you use the definition the long way we're going to do here in just a moment. But you need to see this because since we're doing derivatives all semester, you need to have a good understanding of what derivative means. So if I go back up, or if I just redo it, like here's x squared. What you can do is you can estimate what the slope is at a point. So let's say x equals 2 by taking a point there and a point further down. So you can take a couple of points. And then slope is just rise over run. Same old slope formula. But I'm going to call this point generic xy. So x1, y1 would be x and y. And I'm going to call this point over here x plus h. Actually, instead of calling this y, let's call it f of x. X plus h, f of x plus h. So y2 is f of x plus h. x2 is x plus h. So I'm picking two generic points, plugging them into the slope formula. One point is x, f of x. Another point is scooting over h units. So the second generic point is x of x plus h, f of x plus h. And then this is what the slope formula starts to look like for two random points. Now what can we simplify in this? Okay, so plus x minus x, those just cancel out and go to 0. And ideally, if I want to know the slope right here at this point, how big do I want h to be? H is this distance I'm scooting over to this second point. We can do better than that. Right. And if it's 0, or it approaches 0, that second point gets as close to the first point as we can get. And this is why we had to do limits the first couple weeks. You have to know what this is talking about. So as that second point approaches the first point, as that H value gets 0, this is just the slope formula simplified. We just did the plus x minus x and canceled those out. That's where the definition of a derivative comes from. Two generic points in the slope formula. We want the second point to be as close as possible to the first point. So mathematically, the way we do that is with limits. Now again, we don't have to do this, what we're about to do in question 3, for our AP exam, which is good. But when I took calculus in college, I did have a calculus teacher who told me she was going to put this on the first test and every test all semester. College classes are usually just one semester. And she did, and that, just telling you that because it kind of points out to you how important it is. But what you'll have to do, potentially someday, is you're going to have to say, well, here is the definition of a derivative. I will show you how they ask it on the AP exam. They make it like pattern recognition and multiple choice, but for at least one question here, we want to look at the long process. Alright, so f of x plus h means you go to the function, and everywhere there's an x, you plug in an x plus h. Try to color coordinate this. Then it says subtract the entire function away. And then put it all over h. By the way, you guys did this last year in pre-calculus when you did difference quotient. We made you practice this on the right, the algebra part of this. We didn't make you tie that into limits, but the limits is the easy part. Now, if you wanted to try direct substitution here, you're going to get 0 over 0. So we need to simplify algebraically and make some stuff cancel. So we could FOIL this. By the way, this is not x squared plus h squared. This is x plus h times x plus h. You have to make sure you FOIL it to not miss that middle term. We could distribute the negative 4. We could distribute the negative. It's still a limit. It's still all over h. Just like what we just did, we need something to cancel before it's not 0 over 0. But can you start to see how a lot of stuff is going to cancel out here? Plus 4x and minus 4x and plus 3 and minus 3 and x squared and minus x squared. In fact, everything in the numerator has something in common, or everything that's left over. What does all the terms that are left over in the numerator have in common? Okay, so if we factor out that h as a GCF, then something cancels, and then you can try direct substitution. That guy's derivative, also known as a slope, is 2x minus 4. You're not used to seeing x in a slope because you're used to slope questions always being the same number. You're used to it being linear where it's always the same slope. But just like x squared, it depends on what value of x you're looking at to know what the slope is. So if I wanted to know the slope at 0, I would just plug 0 into the derivative, and I can tell you the slope at that instant is negative 4. If I want to know the slope at 1, I plug 1 into the derivative, and I can tell you the slope at that instant is -2. If I wanted to know the slope at 3, you plug in 3 into the derivative, and I can tell you when x equals 3, at that instant, the instantaneous rate of change, the slope is 2. So it just depends on what x is. It varies. It's not just a straight line now. Okay, so then we can ask some similar stuff, and I basically did this over there to the on the left. But if you want to know the slope of the tangent line, that is like asking you to plug 1 into the derivative. Which is -2. So sometimes you're asked to find derivative, and again, we won't use this process ever again. I just need y'all to see mathematically where the derivative comes from, since you're going to be using it so much. Sometimes we ask you, what is the derivative at a point? So derivative at x equals 1, or very similar work, what's the equation of the tangent line? Now, to write the equation of a line in calculus, you always want to use point slope. Slope intercept is more work and not needed. And you need a couple things to write your equation. So what stuff would we need to write an equation of a line? Okay, and we've got that right up here. So the slope is -2. You have to be told where to make the equation of your line. So x equals 1. That goes in place of x1. What about y1? How are we supposed to find that? What does x1 and y1 represent? Sorry? Okay, it's a point on the equation or a point on the line. So you normally find points by plugging in the x value into the function. When you want points, you use the function. When you want slopes, you use the derivative. So we're just going to plug 1 into the function like you've been doing for years, and you can solve that the y value when x is 1 is 0. If my arithmetic is correct there. 1 minus 4 plus 3. Alright, while you finish copying that down, I do want to graph this one in my calculator because I want y'all to see what it is we're working with. You need to kind of visualize these pieces. Okay, if I typed it in correctly, here is the function we were looking at. We found the derivative a couple questions ago. We found the derivative at x equals 1 a couple of questions ago. This doesn't look good. Something's wrong. Is that original equation x squared minus 4x plus 1? Oh, it's plus 3. Wait, so did this go off too then? Oh, no, that's fine. Okay, so in blue was the original equation. 3 questions ago we found the derivative. 2 questions ago we found the derivative at x equals 1. And in the last question we tried to make the equation of the tangent line, which I graphed in red. So you can you see at x equals 1 how my tangent line touches the original function at just at 1 point? So at that instant, this kind of visualizes the slope exactly at x equals 1. So that's what we're trying to find. But you need to differentiate between the derivative as kind of like a formula This is like a formula to tell you the slope for any value of x. Sometimes we ask for this. Sometimes we're going to ask for the derivative at a specific point. And sometimes you need to pull those things together to make the equation of a tangent line. The work is all very similar, but completely different things, completely different answers there. Okay, so before we jump ahead here, anything that jumps out at you? Anything you want clarification on from that little section? Okay. I don't know if this number 6 fell on the next page or if it's on the top of your page or at the bottom of your page, but we just did that. So basically, just give yourself a quick little sketch here, what I had on the graph. We had the original function that goes through 1 and 3. It's a little parabola. We found the derivative, which is like the formula for slope for any x that we want. We found the derivative at x equals 1 so that we knew the slope at x equals 1. And then we plugged in a point so that we could make the equation of the tangent line, and it should look correct. You know what a tangent line looks like. It should look correct. It should look like a little miniature line that represents the slope at that instant. Now again, without just telling you everything we do all semester, there's lots of applications to this because depending on what your function represents, knowing how it's changing at any given instant can actually tell us quite a bit of stuff. Okay, so all that being said, the definition of a derivative, this is how it gets asked on your AP exam. So again, we won't make you do this long thing like this. I just think it's important for your overall knowledge to know where and why the derivative, the definition of a derivative looks like that. But on your AP exam, they do it this way. Either they use the standard definition of a derivative, which is what we just talked about. There's also an alternate form. This is also just slope formula. And they expect you to just be able to use pattern recognition to answer some questions like these. So I stole a few of these questions from Khan Academy, and I'm going to have you practice this on Khan Academy later on, not today. We're just getting a head start on it, so it's less next time. But look at this question. First off, does this fit the standard definition, or does it look more like the alternate definition? Okay, so if you memorize this, it looks like you should probably know f of x is what? Okay, the part that's right here, which is natural log of x. This part is the function with a plugged in, where a is the x value that you're approaching. So for us, a is e. So f of e apparently is 1, because that's in that location. And then the denominator is x minus a, but we've already figured out that a is e. Okay, and that may be more than we need, but let's see what our choices are. All right, so what are a couple choices we could throw off here? This is just multiple choice. What is the function supposed to be? The function is sitting right here. Natural log of x is the function. The part that's sitting right here. You're just matching it up. That throws it to B or C. This doesn't have the right function. This doesn't have the right function. Okay, and then within this, are we trying to find the derivative at x equals 1 or the derivative at x equals e? Okay, and again, that's, you match up. This was as x approaches e because e was where a is. So from that, we can narrow it down to choice C. So we're not having to apply the difference quotient, but we have to memorize the standard definition of a derivative and the alternate version of a derivative, and then be able to try to match them up. So you guys try this one to the right. So first off, try to figure out which one it looks more like. I guess your choices. And then which one is set up correctly so that you're finding the derivative of cosine at pi. So again, we're not trying to solve and figure out what that's equal to. It's just which one of those things represents the same thing. And I want you to think about that for at least a minute. Try to eliminate some of the choices. Okay, so does it fit this top one more or the bottom one more? What do your choices look more like? Yeah, the standard definition or the alternate form? Okay, all the choices look more like the alternate form to me. So when you're working this, and the derivative is the limit as x approaches a of f of x minus f of a over x minus a. You have this in your head. You get this memorized. I want the function to be cosine, so it looks like we need to have a cosine x here. So that should throw off choice A and I think choice C as well, because those are not just cosine x, they're cosine of pi plus x or cosine of x minus pi. Both of these have the cosine x where I expect it to be. The function is in the top left. Okay, and then we want the derivative at pi. So unfortunately these are both pi. This is going to be x minus pi in the denominator, but both of these are x minus pi. So really what separates them is these two. This is supposed to be f of a, and a is pi here, the number we're trying to find the derivative of. So that would be cosine at pi. So is that B or D? D. They didn't even simplify it. They just left it cosine of pi. But cosine of pi is not pi. So that part of that one's messed up. So this one has the right function at the x value that they're asking you to find the derivative of. But again, to do that, you've got to memorize the standard and alternate form. You don't have to do that yet, but just know that that's coming. So we've only got about 3 minutes here, so let's find a stopping place. We will practice a couple more of those next time. I'll tell you the stuff on the back page, some other things you need to know about derivatives. And part of what we'll do next time is the Khan Academy, where y'all practice working those out.